I just feel like it's a very community-driven conference. It also has a lot of quality, and people are just nice. Hi, my name is Sarah, and this is Asian Conf in Dornbirn.
Amazing venue. Austria is beautiful. Meeting all of the people in the community and getting to go and hang out and ski.
Thank you. Thank you. So, I know what you're all thinking. Can you really read minds? And the answer is yes, because I just proved it. Today, I'm going to be talking about mind reading with intelligent and adaptive user interfaces. But before we get into that, I want to show you sort of a counterexample of this. Now, some of you might know this company named Slack, and some of you might remember a couple months back, Slack decided to add a rich text editor, and it sucks. And it was an unannounced change, and everyone, well, not everyone, but so many people just hated it. And so there were two reasons that we can nail down why this was just a terrible decision. For some people it works, but for other people it doesn't. And that's sort of the point here, is that this is not an adaptive user interface because we're basically forcing all of the users to use this rich text editor, which thankfully they rolled back. And it's also not adaptable. So the difference is adaptable means that we could go into the user settings and we could say, I don't want this rich text editor. Instead, I just want my normal markup or markdown editor. And Slack didn't even provide that option when they rolled out this feature. Now, the thing is that when we're developing applications, we tend to make some pretty terrible user interface and user experience design choices. But it's not necessarily our fault. It's just we're not interviewing enough users. We're not understanding just the different types of users that are using our applications. One example of this, Jared Palmer said that forms are really hard to make. And we see this all the time. It's like, let's say you go on a website, it says, enter your new password. So you enter your password, and then it says, confirm your password. So you start typing, and then the website says the passwords have to match, you absolute idiot. And I run into this all the time. It's like showing validation and just not a very friendly user experience because, simply put, we're not adapting to the user. So here's the main core problem, is that everybody is different. We all have different needs. We all speak different languages, as Ellie talked about. We all even look different, except most of you look European, but that's okay. We'll talk about that later. And so because of this, A/B tests are ineffective because when we do A/B tests, we're forcing users to choose either A or B, and then depending on the majority of which users prefer, we force all of the users to be in this one, either A or B. And the thing is that that could be a terrible choice, no matter which one you pick. Also, we have to realize that user flows are seldom linear. So our traditional techniques of using funnel charts and doing like Google Analytics or Kissmetrics or something like that, and seeing how users go through a flow, that doesn't really tell the whole story because there's many different ways a user can use your app, and there's many different paths the user could take. And so by measuring just one flow, you are measuring only one of many. So we have to improve the way that we do analytics in our apps. One such library that's doing this, it's created by Sam Saccone over at Google. It's called guess.js. And what guess.js is, it's machine learning and predictive analytics for prefetching. And so you could just plop this into your Webpack app or even your static website. And what this does is it uses Google Analytics and it predicts what the next page your user is going to visit based on what your user has visited before. And because of that, we could prefetch that page's contents and load it really fast for the user. So this is an example of one of many libraries that are really good for adaptive user interfaces. Another one, Google recently released a couple months back. It's called React Adaptive Hooks. So if you're using React, you could use these hooks directly in your app and measure things such as CPU, your Wi-Fi strength, your battery levels, all of that, and use that information in order to create a better user experience by making the app more adaptive. So I keep throwing around this adaptive word. What exactly does that mean? Well, adaptive user interfaces, also known as AUI, are interfaces that adapt to the user. So AUI is a subfield of HCI, which stands for human-computer interaction, which is exactly what it sounds like: humans interacting with a computer, computers interacting back with the human. Now, traditionally, when we make apps, it's not very adaptive. We're like, what you see is what you get. This is the form you're going to fill out. This is the way the app works. And if you want it to work a little bit differently, then you could email Slack 20 times telling them your Markdown editor sucks. So adaptive user interfaces adapt to people, not just devices. And so you might think of responsive design as adapting to a device where you might have a small mobile device or a large, one of those big curved 40-inch monitors that cost like $1,000. But adapting to people is fundamentally different than this, because it's like you are the device. And doing that is a lot harder because computers don't exactly have a clear mental model of you as a person. One of the earliest examples of an adaptive UI is Clippy from Microsoft. I didn't work on Clippy. I was a kid at that time. Anyway, Clippy, whenever you were typing, either in Excel or Word or whatever, it would pop up with some helpful suggestions. And so Clippy was being adaptive, also really annoying. So another word for adaptive user interfaces is intelligent user interfaces. And so basically the aim of this is to improve efficiency, effectiveness, and naturalness of human-machine or human-computer interaction. And this is one of the original papers on this, on intelligent user interfaces, written back in 1999. And so that's going to be our goal today, is getting there. So we're going to be focusing on step 0, which is how do we write our apps and model our apps so that we could get to that point. So for example, let's say that you're coding an email client. The user might visit the inbox first, and then there's a bunch of different paths, like we talked about, that the user could take. Either they might want to view the latest emails that they have, or they might want to compose a new email. Now, depending on what they do when they compose a new email, they might want to save it as drafts, maybe not send it yet. I let emails sit in my inbox for days because I forget to send them. Or they might want to send them immediately. The thing is that depending on the user, we might do different things, or they might be more likely to traverse different paths. And so this is the thing that we have to measure in order to create these adaptive UIs. Another example is in terms of improving the user experience. For example, a delete button, typically you would have some notification saying, are you sure? Yes or no. You click yes, and it will delete it. Now, at first, this is nice because you're like, thank you for asking. I'm really appreciative that you want to make sure that I really want to delete this. However, that gets annoying after a while. And so a better user experience might be instead clicking the delete button, having it say deleted, and then having the user have the option of clicking undo. So Google also has a lot of examples of these adaptive user interfaces. I love this, and I've been using it a lot, where you start typing an email, and it will predict what you're going to say next, and all you have to do, if you're on your mobile phone, is just swipe right, I think, and over here, you just press tab, and it's just like autocomplete in your editor. It will predict what you're saying and fill it out for you. So this is another example of an adaptive UI. Now, I work at Microsoft, and I've been talking about Google a little bit too much. So here's an example in VS Code. There's something called IntelliCode, both for Visual Studio and VS Code. Now, this is really cool because it uses machine learning to predict what the next thing you're going to autocomplete. And this could do things like from just methods or properties to even full snippets. So I really encourage you to check out IntelliCode for VS Code as a great example of this. So you see the difference when you press the dot, you're going to see stars. And those stars are what it predicts. It's frozen right now. It looks a lot cooler here. But yeah, just look up IntelliCode for VS Code. Also, adaptive user interfaces are important for distinguishing between what we call power users and normal users or users who might be new to your app. So we want to provide flows for users who just want to get shit done. They want to go from A to B to C, done. But then users who might not be familiar with the app, we might have to provide them more guidance. And that's what adaptive user interfaces can do. However, developing adaptive user interfaces is not without its challenges, and also, this is a cutting-edge topic. As I mentioned, one of the first papers mentioning this was written in 1999, which is 20 years ago, but it is still an active area of research and exploration in the human-computer interaction community. So all of the things I'm going to be talking to you about are cutting edge. They are being implemented in production in companies like Google and Microsoft, as we saw. But what I want to talk about is getting there, so the road to adaptive user interfaces. Now, to do this, we need data. And actually, we need a lot of data. We need big data. And we need to collect all of this data in a structured way and in a predictable way so that we can make sense of the data and actually incorporate it back into our adaptive user interfaces. So how can we do this? The answer is model-driven development, which is, I promise you, a lot different than the development that you're doing nowadays. The development that we do, we're just like, okay, we have a feature, we have a sprint cycle, which is maybe a week or two. Let's just code that feature in and then be done, maybe write a few tests and ship it. Model-driven development is different. Model-driven development means we have to plan everything first. And so what's one of the best ways that we could plan these features? You might know of user flows, user diagrams, things like that, that designers love to use, where we have a very clear outline of going from one state to another state. And if you've seen any of my other talks or follow me on Twitter, then you know that state machines are a big part of that. And essentially, that's what user flow diagrams are. So just a reminder of what a state machine is. You have an initial state, like a sign-in form, or like a sign-in page. You have a finite number of states where the user could travel to, a finite number of events that could cause transitions between these states, and also potentially some final states where you consider your app flow finished. And we prevent errors like this by using finite state machines. So honestly, if you want to find me on Twitter or something, just type state machine and I'll say hi. I'll find you, I promise. So state charts extend on finite state machines by providing things such as hierarchy, parallel states, history, actions, and so much more. And I wrote this library called XState, which allows you to do that. Now, we're not going to be getting too deep into XState. Just know that XState is one of many ways which you could represent these finite state machines and state charts in JavaScript or whatever other language you're using. Now, XState's also available for React. It provides a React hook. I know that many of you are using React. So there's a use machine hook, which is essentially use reducer on steroids. You provided a machine, you get the state, you could send it events. It works as simply as that. You could use it at the local level or at the context-wide level. And coming soon, there's going to be XState for Vue, like a plugin for that using Vue's new composition API. However, XState is agnostic enough that you don't really need to have an adapter to these libraries. You could use it as is. The machine definition works as a pure function, or you could interpret it, and it just works as an event emitter. So, it works with Vue, Angular, Svelte, whatever you use, Backbone, I guess. I didn't try it. So let's take an example app. Let's say that we are trying to make a feedback form, a very simple feedback form, and this is the way it works right now. You click good, it says thank you for your feedback. You click bad, and it asks you why. It asks you to provide feedback and submit it. So here's how it works. You click good, it will say thank you, and let's rerun it. You click bad, you could complain here. You could submit it, etc. Very simple app. You might be thinking in your head, okay, I know exactly how to create this. But let's make this adaptive. So here's a general game plan for how we can make a simple app like this adaptive. First, we have to create an abstract model of how our app behaves. Then we have to measure transition analytics. So between the states, we have to keep track of what the users are doing. Then we could identify which paths we can make adaptive so that certain users get one path and other users might get another path depending on what suits them best. And then we use that analysis for that adaptation. So there's a few concepts we have to learn here first. The first is weighted graphs. So a directed graph, you have nodes that connect to each other with these edges. Weights say, okay, you might be 90% likely to go to success and 1% likely to go to error. And of course, you could measure this with metrics. And so the weight of going from sign-in to success is a lot greater than going from signing in to error. And so that's why when you think of your app flow as a whole, it doesn't look exactly like this, but it looks more like this. And when you visualize it, you could see which paths users are more likely to take. And then you could identify places where users don't really use the app too much. So a couple years ago, I was working on the Visual Studio Live Share plugin or extension for VS Code in Visual Studio with a lot of other really talented developers. And there was this part in the user interface where we had to model all of the different ways that a user could sign in, share, join a session. And these were finite states. Like these were states where a user can't both be sharing and joining at the same time. The sign-in flow was a very sequential flow. And we wanted to measure how users are using the app so that we could identify, all right, there's a lot of errors that users are running into, or more people are sharing than joining. And so by modeling it as a finite state machine and then adding it to the extension, we were able to create visualizations such as this in D3, which this is sort of a force-directed graph that shows the weights of going from one state to the other state. And we were able to identify problem areas, identify how users were using the app over time, and a lot more. All right, so let's go back to our feedback app. So we want to change this up a little bit. Let's say that if the user clicks bad and it takes them to the form screen, the user decides, I really don't want to fill that out. So instead, it should just say thank you after the user does that for a while. So I will go ahead and show that. Let's see. All right, so keep in mind the analytics to the right because that's going to be really important. Let's say that we click bad, and then we really don't want to, we really don't want to submit why we clicked bad. So we're keeping track of that over here, and this is just simple counting. So this is a very simple example of an adaptive UI. So I keep doing this, and I keep clicking bad, and I really don't want to fill out that form, but I'm having a terrible experience. So I keep clicking bad, and then eventually, after it reaches some threshold, it will just say, thanks for your feedback. So I'm like, okay, that's a lot nicer of a user experience. And so that's an example of an adaptive UI. So going back to here. So what we did there was we analyzed the transitions. We measured how we're getting from one place to another place, or one state to another state, and using those measurements, we're able to determine what is the best path for the user to go to. So take this, for example. Let's say that we're creating some sort of Instagram app. We have a login page, and it could go to either the gallery, the camera, or the profile. By default, it goes to the camera. But let's say that over time, we measure the user's interactions with that app. And we see that the user is most likely, this one in particular, to go directly to the camera. So they're more of a producer of photos rather than a consumer. So we could instead create an adaptive path and take them directly to the camera doing that. Now, there's many machine learning techniques that I'm not going to go too deep into right now because, lunch is soon. But one of them is decision trees, where you would take your data, and in order to identify which state should we take our user to next, there's a number of metrics that we could analyze and determine, okay, because of this information, this contextual data that we know about the user, we might do different behaviors depending on that. So I encourage you to look more on decision trees to learn about how you could use them in your applications. Now, when we have this model, this full abstract model of our application, we could determine where users are most likely to go by using shortest paths. And in case you don't know, a shortest path is just the shortest way to get from a starting state to some other state. In this case, we could go between A, B, and C. But with a weighted graph, it's a little bit different. So let's track the metrics here. Let's say that we're moving through, we're tracking things such as the target state, the source state, the event that happened, and the time that it happened. So based on these metrics that we collect, we could say, all right, even though going from A to B to C is the shortest path, most users are likely to go from A to D to E to C. So, in other words, A to D to E to C is actually the shortest path. And so this is where it gets a little bit tricky and mathematical for analysis, bringing machine learning into it, and things like higher order Markov models, which, like we talked about, let's say a user is more likely to go from A to B than A to C. But depending on the state before, the user might be much more likely to go from A to C than A to B. So now we have to take into account all of the different states that happened before. And so these are a few more advanced topics. And so we could also use deep reinforcement learning, which combines machine learning and reinforcement learning together in order to predict the user's behaviors. Now, reinforcement learning is really cool because we're essentially training an agent to predict the user's behavior, and we're punishing it if it doesn't predict it accurately, and we're rewarding it if it does predict it accurately. And based on these rewards, when a user uses the app again for a new time, we could be able to predict it more accurately. Now, just a quick primer on how reinforcement learning works. You have an agent. That's like your AI robot that's going through the app and doing all of these actions and making sure that those actions are the right actions. And so the way it chooses these actions is via a policy. And so the environment, we analyze the action on the environment. If it was a good action, we give the agent a reward. If it's not, we don't give it as much of a reward. And so that action causes a change in state. Now, deep reinforcement learning is about taking that state, putting it through neural networks. Don't ask me what this means, I have no idea. And then eventually getting an action. So you might be thinking, seriously, can we really use reinforcement learning in applications? And the answer is yes, and you're just going to have to take my word for it, or I could just show you a demo right here. So what I did over here was I created a very simple tic-tac-toe game, and I used finite state machines just because that's sort of my thing. And this is a very simple game where you play, and let's see if that was a terrible move. Okay, 0-1 that time. But when we play, what I'm really doing over here, and I did this for about half an hour, and we could see that there's actually a different frequency in which we play certain squares. So we see that the center one is played a lot, and as we go through the game, the frequencies change. And so you see over here, this is a game position that has never been played before, which is why all the squares are gray. So what we could do is we could feed that right back into an agent and use reinforcement learning. In this case, I'm using simple Q-learning in the browser in order to predict what the next move is going to be. And so what that means is that I could instead play against an AI. And so I'll do that over here. You can see the training values over here. This is used to determine the reward you get for playing a certain square. So now this AI its goal isn't to win. Its goal is to play like a human. So let's see if it does that. So let's see if it blocks me. It did block me. Okay, so let's say I go here. It blocked me again, which is great. And so this time, we're going to tie. So now let's do something again. Let's play really dumb, and hopefully it will win. So there we go. So it's using a combination of frequency based on the analytics that we got, playing the game over and over again, combined with reinforcement learning. And so, thought that was pretty cool. I also have a video here in case the demo fails, which it did not, which I'm really happy about. All right, so in short, we have an application that you create, and we create an executable abstract model, which is the state machine of your application. Then we track using metrics, and in XState or any other event emitter library or subscribable library, this is just, you do it in one place. You do it wherever the state is being updated. So if you're using React, you could even put it in a use effect or something like that. Then we could take those raw metrics and provide it to things like Azure Analytics, Google Analytics, Segment.io, Mixpanel, Kissmetrics, whatever you use in your applications. And then we feed that back into the executable model and just identify areas for adaptability. And then we put that right back into the application, so we no longer have to iterate through many weeks of, oh, does the user really want this? What's the best user experience for all users? Instead, we could adapt the application as the user is using it, which I think is really powerful and really exciting. So even though this is a cutting-edge topic and there's nothing, there's not too much about it yet, I think it's really exciting, unlike React's concurrent mode. So the dev experience in representing your applications as abstract models, you have determinism. So you could identify what state you're going to go to based on the current state and event. You have visualization capabilities, communication between developers, designers, and other stakeholders. You could generate tests for this using model-based testing. You could even use that data and provide simulation of just modeling how users might use your app without a user actually being there. And so all of this translates to a really good user experience because we're capturing analytics from the user, using those analytics, and feeding it back into these state machines that we've created for our apps. So XState has a lot of libraries to help, and I'm also working on an XState analytics library. XState View is coming out soon, as well as many other libraries. So if you want more information on that, you could just visit xstate.js.org/docs. And also, there are visualizations. So if you go to xstate.js.org/viz, then you'll see that you could take your machine definition, copy and paste it right into this, and then be able to just walk through it and verify that your abstract model of the application works exactly how you expect it to work in your head. It works exactly how your designers expect it to work. And you could use this exact same code right back in your application. So sort of like Jared's Formic Cloud, this is basically like XState Cloud. I don't know, I didn't really give it a name yet. So there's a lot of helpful resources. The world of state charts is a really great introduction to what state charts are. We have a Spectrum community where a lot of people ask questions about state charts and XState in general, and of course the XState docs. So overall, I want to make your code do more using finite state machines, abstract modeling, model-driven development, and more. Thank you so much, AgentConf.
Didn't even need to do the 3, 2, 1.
Hi, I'm Clemens. Thanks for the talk. I've got a question. As far as I understood it, adaptive design or development lets you create kind of a customized user interface for each user by using these machine learning patterns, right?
Correct, yeah.
What I'm wondering is, isn't it kind of error prone this way when you've got like thousands or millions different versions of your user interface out there, and people may report a bug or something, and you have to figure out actually which version of the UI are they using?
That's a really good question, and actually, that's one of the biggest questions in the human-computer interaction community about adaptive interfaces, is that the worry is that these user interfaces can make your app a little bit less predictable, actually. And the truth to this is that if you have an abstract model of your app, the way that finite state machines work is that's how it's always going to work. Nothing is going to change. So when you build that adaptivity into your app, you still have the exact same transitions. You're not like making a random choice or whatever. And so the way that you could test and predict how you could use your app is two ways. First way is you're providing those analytics, like let's say as a JSON object or something where it's like the user is this % likely to do this % likely to do that. And so when you're testing, you could provide those values and say, given this set of metrics, how is my app going to behave? So it does become a lot more predictable that way. And the second one is actually, it's called mixed interaction mode. And what that means is you're providing adaptivity and also adaptability. So you provide some adaptivity where it's like, okay, let's have a menu, like a menu list with the most likely items the user is going to select at top. But also, if the user needs to customize anything, then they can go into the settings panel and be able to tweak those values themselves. So, hope that answers your question.
Yes, thank you.
I just want to say one thing. Please don't get up, because there's something after the question that's important for the next talk. I saw some of them get up, but I couldn't stop David from speaking.
Sorry.
No, it's okay, man. You're the star here. It's fine. Does anyone else have any questions? Oh, wait, this one isn't working? Okay, cool. That doesn't make any fucking difference. I'm very loud. 3, 2, 1. Okay. Oh, there we go. That was like 0.25, man. You got really lucky there.
So about the tic-tac-toe game.
Yeah.
You didn't give the agent any information about how to win the game or anything. The agent just decided his action based on what a human would do, basically.
Exactly, and I think at the moment I don't even understand half the code that's in there. In fact, I could actually show you real quick just an example of what it's doing. Okay, yeah, so I have like all right, here we go. Here's my, basically my inputs. What I did was I used there's actually a Python tutorial, a very simple Python tutorial on using queue-based reinforcement learning with tic-tac-toe, and I adapted that directly into here, and I used the state machine to help. And so that's why you have variables in here such as LR, which is the learning rate, the decay gamma, like is 0.9, and these seem like a lot of magic values, but that's basically saying, as I play the game, if an action is considered good, maybe don't consider it that good, like maybe give the reward a little bit less, because we don't know for sure if that action was good or not until the game was won. And so basically, it is very ugly code right now, but it is a copy-paste of a Python reinforcement learning tutorial. So it is actually learning. And that's why if I played poorly, then the machine would also play poorly. And that's why the goal is for the machine to act like a human instead of trying to win.
Thank you.
Does that make sense? Okay, cool. Okay, so that's gonna take a while. So how you doing?
Doing great. How are
He
you?
has to like go up the stairs and shit.
What's for lunch?
I've heard that it's like pork burgers and vegetarian options.
Sounds great.
I know, I'm super excited.
Hello, thanks for your talk. One short question. I've seen some advisors in the world of the internet to skip the whole state libraries like Mobex or Redux or whatever, and just use Xstate for your React application. It's hard to imagine how to use it in a real world example. I mean, when I've got a really big React application, how can I imagine that? Do I not use state at all, and everything is in a state machine of Xstate, or is it a mix of both?
So that's a really good question. Actually, all the questions were really good. With that one in particular, I actually just wrote an article that upset a lot of Redux people. It's called Redux is Half of a Pattern, which I describe how Redux is half of a state machine, and I actually don't mention XState at all in there. But basically, what I would say is take a step back even further. Even though I created XState, what I recommend to people now, and I also do consulting with React training, in which we give React workshops teaching how to use hooks. And so what I would say is take a step back, don't use Redux, don't use MobX, don't even think about any other state management library. Instead, start with basic hooks. Start with use states, and then once your state becomes more complex, you go to use reducer. And use reducer is when you could apply these finite state machine techniques. I mean, you're going to be using a lot of switch statements, and so once that gets more complex, then you could think about using something like XState, which provides a use machine hook, which, like we talked about, is just use reducer. Because the fact of the matter is that a lot of the state in your app is distributed, which means local and localized, and instead you have components communicating with each other, and that's sort of antithetical to having a full atomic global state. So what I would suggest to you is start small. Use reducer is going to be your best friend in React, and if you're using Angular, then the scan operator is great. If you're using Vue, then I don't know. I haven't done too much Vue, but yeah.
Okay, thanks. So that means it's totally legit to have both, right? For example, a local state in your component is still a normal use state property.
Yeah, or use reducer.
When we are talking about fetching data from an API, it's fine to use something like XState too.
Yeah, you could use XState. So use machine is basically use reducer and use effects combined. Otherwise, you could even, if you, I don't know, if a year down the road you start using XState and then you're like, I really hate XState. All you have to do is refactor that to use reducer and use effect, and you get basically the same thing.
Okay, thank you very much.
Mm-hmm.